Hey guys, welcome back to the shop. Here we are again, ready to forge something cool, sharp, and useful. So grab a piece of 1095 high carbon steel there, and I'll combine that with some sawmill blade 15 and 20. So I'm forging a little neck knife, and I'm going to give this away since we've reached beyond 10,000 subscribers now, thanks to you guys. So I'm going to give this away. One of you guys are going to be the lucky winner here, so stick around to the end and I'll tell you how to enter to win the knife. So typically when I have gone to clean the surfaces off of my steel before stacking the billet up for the forge weld, I've always used my flat work surface or platen on the grinder. And I've seen other knife makers or bladesmiths use a round wheel. This is the first time I've tried it, and it actually works really well. I wish I would have tried it sooner. It's easy to kind of round off the very ends of the pieces of steel. I don't know, it didn't seem to be that big of a deal actually, but because of the much smaller surface area that you're contacting with the grinding belt at any given time, builds up a lot less heat and cuts a lot easier. So as long as you have a flat piece of steel to begin with, it works really well. So we'll get this stacked up. We've got a 21 layer billet here. And go ahead and dip it in the old diesel. Get some hydrocarbon goodness here. Protect the surface of the steel a little bit, and leave behind some carbon deposits, which helps with the forge weld. Brings the necessary forge weld temperature down a little bit. You really can forge weld with just diesel or some similar product, provided your billet's nice and tight and your forge atmosphere is at least neutral or carburizing. But I decided to go ahead and use some flux here just to make sure everything was good. In the past, I've used large quantities of flux, and that does a number on your forge liner, no matter what type it is. So here I'm trying to use as little as absolutely possible. And I think the more forge welding I do, or that anybody does, you gain confidence and figure out what's necessary, and kind of you refine it, and you don't need a ton of flux as long as you've done everything else as you should, and your forge atmosphere is good, all that kind of stuff. It's really a combination of a bunch of different things, and you sort of hone in on that over time, I guess. And so anyway, I'm just grinding off the uneven edges there. The 15 and 20 pieces are a little wider, and I don't want to keep forging and create an inclusion or a cold shut that's going to show up later. So we've got a nice clean billet to press out here now. And this is a lot of fun to squish hot steel. All this stuff can be done by hand, but it's a lot of work, and especially if you're trying to make money at it, it's sort of time and cost and effort prohibitive. Of course, this particular knife I'm not making money on, but as a general rule. So we've got the billet drawn out here to about 10 inches and 10 and a half, something like that. That'll give us a little room to cut off the end of the billet that's as typical. It's not going to have the greatest of welds on it. So we'll get that cleaned up and restack it into 3 pieces, and that'll give us a layer count of 63 minus whatever we've ground off cleaning up the billet. So obviously less than that. That's a pretty low layer count really, but one thing to note about pattern welded steel is that you can go pretty high layer counts. I typically like to do 200 to 300. That's a decent layer count. I find if you kind of go up above that, it gets so fine that it's hard to see anything. But you really don't see all of those layers anyway, typically. So in this case, what we're going to do with making this twist pattern, we're actually going to essentially turn those layers sideways, and we're actually going to be able to visually use all of the layers that we actually have. So it's gonna turn. Well, you'll see how it turns out. Anyway, let's twist this thing up here. And this bar, I've knocked the corners off on the press. It's not round, but it's more octagonal, I guess. And I'd say 1.125" wide. And I had it in and out of the forge, I think 4 times, like 4 different heats to get the number of twists in it that I wanted. And I did not count them, but went pretty tight on it. So something to, and you can, as long as you have the right heat on it, you can twist quite a bit. I mean, like I say, you can count them. I didn't get all of them in here, but all of the twists in the video, but it's pretty tight. I have actually twisted a billet off before when I had it too hot, so you got to watch that. But if you just do it near a welding heat, it's not bad. But the thing about twist Damascus is once you start forging it out, if you forge it out lengthwise at all, which is, typical, very easy to do, you're going to stretch those twists out, and if you don't have quite a good twist in it, you can easily nullify or just kind of cancel out most of the twisting you've done, and it's not going to look very twisty. Did I say twisty enough? So here I made a big mistake. After I twisted that up, said it again there, I went ahead and just smashed it. And what I should have done, which didn't dawn on me until several hours later, is actually forge around the circumference of that bar. And that would have, I think, really helped to close up some of these nasty, disgusting inclusions. Like, they look like cracks. They're not cracks, but they would turn into something like a crack if I were to continue forging without getting rid of them. So that was kind of a bummer, but live and learn, I guess. I was able to grind them out and enough to the point where I could just forge the bar down and not have to worry about cold shuts throughout the piece of steel going forward. So that's pretty important. But yeah, next time I do this, I'll make sure to do some forging around it so that we minimize that as much as possible. So, like I was talking about the twist, you can go ahead and really focus on forging it widthwise and preserve more of that twist. And I didn't do that here. I knew based on how much I had twisted it that I'd still have a decent twist pattern in it. So we'll just chop off a piece here for our knife and get that in the forge here. Now I'm just going to forge in the tip a little bit here. And once again, once you've put the pattern in your steel by whatever means or whatever pattern it is, which we have done here by twisting it, if you do a whole bunch of forging on it, you're going to really distort or even, just mess up the pattern. So I'm not going to forge the bevel in. I'm not going to forge the handle, contours or anything like that. And I'm not saying that it's wrong to do it that way. It's just going to change the pattern. So every time you move material, take away material, or add material on a piece of pattern welded steel, you're going to change the pattern. Which, honestly is part of the fun. But I'm trying to preserve the twist as much as possible here. So using the chisel to clip off this corner here after I've forged the top of the blade down a little bit. This is one of the simplest ways to get a knife, the end of a knife blade forged in. And obviously it's not as much forging as you would do if you didn't use the chisel. But some guys actually prefer this when they're working with pattern welded steel because it's overall less stressful on the weld. Now, if you have a good weld, you shouldn't have anything to worry about, but at least that's what I've read or heard. So something to think about. It's also just a pretty efficient way to get the tip of the blade formed on your knife. So that's all the forging I'm going to do on that. And here I'm spheroidizing the tang of the knife here. And of course the camera shows it way hotter than it actually is. It's just a dull red, and you want to keep it below austenizing temperature. And then right here that you can see, that's a little better representation from what you can actually see in the camera, which is not what it actually is. Yeah, just the dull red, that'll spherize that carbon, get it out of our way, and allow us to actually drill some holes. Clean the scale off it a little bit here. So throughout this project, you'll see me using Empire abrasive grinding belts, and they were kind enough to supply the ones that you see me using here, the ceramic belts, for this project. And these are the best ceramic belts that I've used, and I really like them for just taking off material, grinding the bevels, etc. It lasts a long time. I'm not using new belts here. I didn't use any new belts at all in this project. They're belts that I ground other knives with, and they're still going strong. So anyway, you can check them out in the link. Click on the link in the description below. That helps the channel out a little bit. And you can also use promo code FireCreek, which also helps the channel out, so I appreciate that. So you can see our spheridizing was quite successful. No trouble at all drilling through here. It's pretty easy to do on the simple 10x steels or stuff that doesn't have any serious alloying components or hardening alloy components like chromium and stuff. So I'm trying to make kind of a skeletonized handle here. And I've got this 33/64 drill bit, which my drill press is way too fast to run. So you saw me standing on the table there literally to get enough pressure on my hand drill to drill through the steel. And it's soft enough and everything like that. It would be nice to have like a milling machine or a metal drill press that's slow enough, a double reduction or something like that. But we got it done, and you can see I messed up the hole spacing too. I don't want to talk about that though. Anyway, so put a rough grind on here, which I typically don't do very much anymore, but I typically forge the bevel in, which I didn't do here. So that's why I'm doing the rough grind. And I like to do it this way. I don't know that it's necessary per se, but I like to do it this way so that there's less material, less steel in between the finished location of the edge on the finished knife and the coolant, so that we have the best, most efficient cooling process for that edge steel. It's just how I like to do it. And like I say, typically I would forge the bevel in to accomplish that. So here we're doing the normalizing cycle, and of course thermocycles to follow that up. Very important part of the process here. And what's next? Well, of course, would be the quench here. Into Parks 50, which is a very fast quench oil necessary for steels like 1095, which is the main steel we're using here. So we've got it tempered up and ready to finish grind. So finish grinding in the bevel, and then of course the entire surface of this little blade, handle included. Because we're etching out this Damascus pattern, we have to make sure that the decarburized layer of steel is completely ground away everywhere. If you leave that on there, it would, I think actually there's a little spot right at the very end of the knife that I didn't grind off because of the corner was kind of ground away a little bit, and you can see just a tiny bit of, it looks like a grainy surface. Anyway, it doesn't, you wouldn't be able to etch and get a good pattern out of it, so it has to come off. So I originally started trying to make this a little more chunky, a little thicker. I wasn't sure exactly how far I wanted to go with that, because I wanted to keep the weight down, but I did want a little thicker. You don't want a super thin tang or handle there, because you're going to be holding on to it. But I think I got a happy medium between weight and comfort in use for the knife that it is. So put a nice radius all the way around the handle, and it's pretty comfortable to hold on to. I was trying to do more like a 3-fingered grip, and it's a 3.5-finger grip really, so it's not bad to hold on to actually. So that part turned out pretty good. So now on to the hand sanding, which of course is always everyone's favorite part. I mean, there's sort of an advantage here. You don't have to put a handle on this knife, but flip side of that is you do have to sand the entire thing. So I guess it's a little bit of a trade-off. I have to get all the scratches out, all the previous coarser grind marks or sanding marks off, so that we have a uniform finish on the whole thing. And there it is. I forgot to stamp my logo in there, so I went ahead and etched it with the electronic etch. So into the ferric chloride we go. And I had it in and out 3 times. I wanted a nice deep etch on this, so that through use, you're not going to have to worry about, ever losing the pattern. It'll be there. And a lot of guys will put their knives in coffee, do a coffee etch after the ferric chloride, which really darkens the carbon steel. I didn't do that here. It's with the use this knife is hopefully going to get that kind of thing isn't going to stay on anyway, really. So it's I didn't do that. Pattern is still pretty nice. So I went ahead and tempered out the tang and the spine of the blade, so that I want it to be a nice tough little knife. The edge is heat treated and tempered to a good hardness for some really great edge retention for this steel. But I wanted the overall knife to be tougher than that, so you temper that out a little bit and combines the toughness of the blade with the edge holding capability. You've got a great little knife. It's a bit of razor sharp edge on there, hair popping sharp, as they say. So this is the first knife quite like this that I've built, but I'm pretty happy with how it turned out. It's going to make a great little knife. So there's the finished product right there. So let's talk about how you can get a chance to win this knife. So before we do that, if you're not subscribed to the channel, I'd sure appreciate it if you do that and hit the notifications bell. And then if you would, go ahead and leave a comment below about what you like about the knife or how you would use it in your EDC, something like that. And then to get a chance to win this knife, click the link in the description, the video description. It'll take you to a third party, and you'll have to click on a button that'll take you back to this channel. But then you'll be able to enter your name and email, and a week from today they will pick a winner, and I'll contact that winner, and we'll go from there. By entering the giveaway, you are certifying that you're legally able to possess this knife, and you assume all responsibility for possession and use of it. And I do not assume any responsibility for your possession of it. YouTube is not affiliated with this giveaway, nor is any other company. I think that about wraps it up. Anyway, I appreciate you guys watching as always, and we will see you on the next video.